Hi everyone and welcome back on my channel. In today's video, we built a machine learning app with a model from Hugging Face, and then we built a FastAPI app around this and Dockerized the whole thing. And for this, I have a very special guest here with me today, Sebastián Ramírez. Sebastián is the creator of FastAPI, Typer, and other very cool open source tools. So I'm super excited that you're here today, Sebastián. Welcome.
Thank you very much for having me. Very cool. Let's see how it works. Let's see how it goes.
Yeah, let's see. So Sebastián will give me some help along the way. And by the way, the folks from Docker were kind enough to provide some swag. So if you're watching this video live, then there will be a giveaway during the video. And for this, you have to monitor the chat. And the only thing I already prepared is the model code. So let me share my screen. So the model is a vision and language transformer that can process both images and text. And here, for example, you see you can send an image to it and then ask a question. For example, here, what's the animal doing? And to get this running, you need to install the transformers library and PyTorch. And then here you can grab this example code. So I already did this and pasted it here in Visual Studio Code. And then, as I said, you need to install the transformers library and PyTorch. So I also already have a virtual environment with this here and installed this already. So now we can, for example, run the code. So let me quickly test this by running Python, and then I called the file modelstarter.py. And as you can see, we get a predicted answer with the response. And now, before we turn this into a FastAPI app, I want to explore this in an interactive session. So this is a very cool tip I got from Sebastián. So maybe, Sebastián, you can talk a little bit more about this interactive session.
So yes, of course, I think this is one of the coolest features of this editor and modern editors, is that I guess some of you have probably worked with Jupyter notebooks, and there's a way to have the equivalent of a Jupyter notebook inside of Visual Studio Code. And this is what is called an interactive session. And what it actually does is that the editor communicates with the Jupyter kernel, with the internal parts of Jupyter, so that it can show like all the interactivity and all the interactive window and everything inside of the same editor. And it's actually quite simple. The way you use it is that you go to the line that you want to select, for example, like, I don't know, import requests, or from transformers import this. Mm-hmm. Then you just select that line, and then you trigger like the multi-command thing that in Mac is Command-Shift-P, or in Windows it will be Control-Shift-P. And that shows you like all the commands that are available. And then you can search and like start typing. Run in interactive window, and that will show you the available commands that are for that. And then you can see that there's Jupyter run selection line in interactive window. And if you select that line, then that if you just hit enter in that line, that is normally is gonna ask you, hey, this needs this additional component from Jupyter called IPyKernel. Should we install that? And then you just click yes, and then it will install it. If we have it already installed, then it's just gonna connect directly, and it's gonna start the Jupyter kernel locally in that same virtual environment, and then it's gonna run that line that we selected. The cool thing is that now you have on the left side the final code that you're gonna use. That can be like the production code, and on the right side you have an interactive window where you can explore that same code without having to switch back and forth and copy paste from Jupyter kernels and things like that. So now we have the transformers components in this interactive window, and we will be able to like just trigger auto completion or like explore that right there. The cool thing with this is that you can select lines of code, or like even sections, even pieces of code, and then run those sections in the interactive window. And that allows you to explore a bunch of things, just interactively and manually.
So maybe let me try this again. So now I will select some more files, some more lines. And now I say Command-Shift-P, and then run selection in interactive window and enter. And now, now it will send everything over to the notebook.
And one of the coolest things is that it can give you, it has a lot of the interactivity that you will have with Jupyter Notebooks. So for example, if you have an object that is an image, like the variable image here, and then you execute that, then it's just going to show the actual image there in the interactive window. So you can explore these things, and it can help a lot, interactively exploring what is the code actually doing.
This is super cool. So yeah, like I said, like Sebastian said, now you have access to all the variables and can explore them. And yeah, I think this is super handy to explore your objects while you write the code. For example, let me type encoding, and I think now if I will also get auto completions. So yeah, we could explore this some more. And yeah, so very, very cool tip I got from Sebastian. So let's also, for example, let's select the rest of the code. And I think you said you have a shortcut, right?
Yeah, I have a shortcut configured that is Shift Enter, but I think by default is not configured. But like that way, whenever I'm writing code, I think you could actually just it actually says that it's there, Shift Enter. I don't know if it works. Did it work? Seems like it worked. Yeah.
Yeah.
Maybe that's the default now, because at some point it was not the default and I had to configure it to be the default. But that means that when you have the shortcut enabled, you can just Shift Enter, select a piece of code and then Shift Enter, the same Shift Enter that you will do if you were in Jupyter Notebooks. And then that just runs that selection in the side. It's very efficient. The iteration is very quick, it's very convenient.
Yeah, I think so too. Cool. Yeah, so now, for example, you have the model outputs, and often it's not very clear how you get to the actual item you want from this. So then here, for example, you could explore the outputs and then see that you need the logits fields. And yeah, so, but yeah, this is just one tip we also wanted to show you in this video. But now moving on. So now I think the next step when we want to put this into a FastAPI app is, I think we should turn this into a function, right?
Yeah, it will make sense.
Yeah,
it will probably make sense to have the model loaded right there at the top of the file, not loading it inside of a function, because otherwise we could end up loading the model for each request. So I think most of it is just like that, but then like a function that does like the rest of the logic of getting the inference from the model.
Very good point. All right, so let me create a new function, maybe down here, and let's call this, for example, model pipeline. And now as an input, I think we want to pass in the text as an input. And would you use type annotations here right away?
I would use type annotations, just because if I use type annotations there, I get auto-completion inside of the function.
Yeah.
The editor will be able to know that, hey, text is a string, so it will be able to give me those auto-completions. So I end up just using type annotations pretty much everywhere, just to get that feature.
Okay, cool. So yeah, let's send in the text as a string and then also the image as an input. And I think this can be a pillow image. And then we basically need to do the rest of the code in here. And then in the end, we need to, let's just return this part, I guess. So this is the actual final label. Yeah, so now we have the model function. So I think now we can turn this into a FastAPI app, right?
Yep. Maybe in line 11 that there's an image that is being opened. Maybe we can comment that out so that it's not being an image is not being created all the time.
So we actually don't need all of this anymore. Also,
the rest is,
to have it fully correct, we also don't need requests now. We just need to make sure that we get the image somewhere else. So we want to do this with a file upload later.
Yeah, definitely.
All right, so now let me create a new file. Do you have, by the way, like any best practices, how you set this up? Would you do this? Would you put this into a new directory, or just?
I will normally just create a new file right there and then move it to a new directory whenever it actually grows. I think, I think it's even more important than to have a very predefined structure that is like applies to everything. I think it's more important to be able to refactor quickly according to whatever is the things that need to be done. So yeah, I think
that's
this
a very
is fine.
good point. Okay, yeah, so let's keep it simple in the beginning. So main.py, and now, for example, we could import this right away. So from model starter, let's rename this. Let's rename this to maybe just model py, or yeah, let's just do it model py. And then we can say from model, we want to import the model pipeline, right?
Yeah.
And now for FastAPI, so I think I already installed the requirements, but yeah, just for completion, I think we need to do pip install FastAPI, right?
Yep, that's correct.
And also...
And then probably also Uvicorn. And it will probably it's probably better if you put pip inside of quotes, install Uvicorn, and then like Uvicorn inside of quotes, and then Uvicorn standard. Yes, that's so standard, that it has like all the standard features, including the thing that gives it massive performance.
Nice. Okay, so now we have this installed. So now we say from FastAPI import FastAPI. And then,
no.
Yeah.
Yeah, no. Because like you actually know like everything. I don't know if I should just like say just to be speaking, but like yeah.
Yeah.
We
so
will just like
actually,
create a map that is an instance of the FastAPI class.
So yeah, what I often always do is just go to your homepage, because I think the documentation here is excellent, and then just simply follow the getting started part. So here, yeah, we again have the pip install FastAPI, pip install Uvicorn standard, and then I just grab the getting started code basically. So let's do the same here.
That makes a lot of sense.
Yeah. All right. So now we have a home route that simply returns hello world, and then there is another route. So maybe you can quickly explain what this will do.
Yeah, so what we are doing, we are creating an instance of the class FastAPI, and then we use the @ symbol, @app.get. So this @ whatever, for those that might not know, this is called a decorator, and what it says, what it does is that it tells FastAPI, hey, do your thing with the thing that you have below. So whatever is it that you do with this, do it with the thing that you have below. So we are telling here FastAPI in the first line, in the line 10, we are telling FastAPI, hey, whenever someone sends a request, an HTTP request that is using the operation get or the method get, like an HTTP get, and it goes to the root route to just the slash, then this is the function that I want you to use to handle that request, the function that is called read root. And then this function is just returning a dictionary. Then FastAPI is going to make sure that it converts that dictionary to a JSON payload, and it's just going to return that. Then in line 15, what we are doing is that we are saying, hey, FastAPI, whenever someone sends an HTTP GET request that goes to this path, and the path is /items/, and then we have, you can see these curly braces, and then inside of the curly braces, we have item ID. So item ID is going to be a path parameter. So this is going to be variable. This is going to change whenever someone sends a request. If someone goes to /items/5, then this is a 5 is going to be the path parameter. And then what FastAPI is going to do is that it's going to extract that 5 or 7 or 10, like whatever is the item ID. It's going to extract it from the path in the URL, and it's going to put it in the parameter inside of the function read item in the parameter with the same name, in the parameter item ID. And now, because we add the type annotation saying like, hey, this item ID should be an integer, FastAPI is going to make sure that what we receive is an integer. So it's going to do data conversion. It's going to extract that piece of, it's just a long string. A URL is just a string. But FastAPI is going to extract that string containing the number. It's going to convert it to an actual integer. so that our code inside of this function is going to receive an actual integer. And if what we send in the path is not an integer, then the client is going to receive a response saying like, hey, this data is invalid because this thing is not an integer. So we get data validation and data serialization just from these type annotations. This is not something that comes with Python. This is something that comes with FastAPI. With Python, just by using the type annotations, you get auto-completion and inline errors, and you get like the certainty that the code is correct. So that's like totally worth it in my point of view, just to have type annotations just for that. But then when you are using FastAPI or other of these tools, then you get like these extra benefits of like data validation, serialization, and like also automatic documentation. I think we'll probably see the automatic documentation in a bit.
Yeah.
But this is what we are doing here.
Yeah, very cool. And one more thing I noticed, so the getting started code has the normal function definition, but I think you can also do it async, right? So I could also say async.
So the thing is that underneath FastAPI is an async framework, so it does like everything async underneath. But you don't have to use async, and when you don't use async functions, then FastAPI that's also like a way to tell FastAPI, hey, whatever is the code that I'm running here, it could be stuff that is blocking. So it might not be compatible with async and await, like compatible with using await internally. So if we run this inside of an async function, it could end up blocking the event loop and degrading performance. But what FastAPI does is that it does let's say the smart thing, and it runs these functions that are non-async. It runs them on a thread worker, on a thread pool, so that you can get like the best performance and like the best practices by default without any extra effort. When you are doing machine learning, in most of the cases, you will not want to use async. And actually, like almost most of the scenarios, you don't want to use async and just want to use normal, regular functions. And then whenever you have like a path, like a region of code that is a hot path, is something that is used a lot, and then you need to squeeze and optimize performance for that specific region, then it makes sense to optimize that and to use async inside of that. But apart from that, most of the cases you end up just like better off just using regular functions, and then FastAPI does the smart thing. It's just that you have the convenience of like, okay, if I need it, I will be able to just use these other tricks. But like you don't have to start doing like that, all that complexity right away from the start.
Yeah, right. Yeah, I think that was a very good explanation, because I know that many beginners are not sure, should they use the normal function or async right away to optimize everything. But yeah, so let's keep it simple and have the normal function definition without async. And now we could run this already and test this, right? So for this, we have to run uvicorn, then it's main:app -- reload. So let me see if that works.
Main:app is the equivalent as if you say from main import app. So whatever goes before the colon is from blah, blah, blah. And whatever goes after the colon is the import. So we are telling uvicorn, hey, go to this file called main and import the object that is called app, which is the FastAPI app. That's what it means.
Yeah, and it's working. So as you see, it's returning hello world at the home route. So now we can get rid of this actually. So now what we need for our machine learning model is we want a app.post, right?
Yep.
And
to be able to send a body with the image, I guess.
Yeah. So let's call the route/ask, for example, and then we define a ask function. And here we also want to send the parameters, right? So we need the text, and this has to be a string. And now we also need the image, but for the image, we need to upload it. So I think a FastAPI has a, what's it called? Upload file.
Upload file. Yep.
Yeah. So the image is a upload file. Now we can use this inside. So now we need to, the first thing we need to do is to turn this into the actual content, right?
Yeah.
And I think for this, I need your help a little bit. So what do you have to say to get the actual bytes?
So the thing is, this upload file by default is like compatible with async and all the stuff. But we want to have so by default, like the default methods are async and stuff. But internally, it actually uses a standard Python file. So if we do image.file, then that object, that attribute file, that is the actual file. So then we can interact with this as before. So we can say file.read, and then that will give us the bytes.
All right. So now this is let's call this content. And now we need to also turn this into a pillow image. So we can say from pill import image. And for that, we also need to import IO. So now we can say the image equals a image. And here we say IO dot, what's it called? Bytes IO. And here we can put in the content. And now we can apply
maybe instead of bytes.io, because bytes.io, what it does is simulate a Python file. Maybe instead of simulating the Python file, we can pass directly image.file directly to this image.io. Although, like maybe it's good just to have it like this, just to have like all the additional options in case someone needed to send the code in a different way. But yeah, I don't know. I think it's probably possible to just like pass directly image.file. I don't know.
Yeah, okay. So let's try that. So you think here I can say image.file?
Yep. Without reading the content there.
All right, so let's try it like this. And now we can send this to the function. So let's call this, for example, result equals the model pipeline. And here you can see we get the suggestions. So it needs the text first, which has to be a string, and then the image. So let's put in the image as well. And then what would you return here? So would you simply return this as a dictionary, or do you have like any preferences?
We can just start with returning the result directly and just do the bug and see like if it works. And then if it works, then we can also like try to see if we need to return like, like additional metadata or something like that. We can just start with that.
Okay, so let's run this. And since I started this with -- reload, it should already work. So now I just have to go to the, this was your home page. Yeah, so now here I have the localhost, and now I think we can go to /docs.
Yeah, nice.
And now here you see all the endpoints, and here you see this is a post endpoint that now needs a text and the image, and then we can click on try it out. And as a text, so let's ask how many, or let's select the image first. So I have an example image. If I find it. Let's select this one with the cats, and then we can ask how many cats are in there. Then we can click on execute, and we get a server error.
Eternal server error.
So let's see what module object
is not callable. Okay, maybe the thing about the image.file didn't work. I don't know if it's wait, image, yeah.
So I think it's image.open, and maybe the second one will also work. So, but let's try this one.
Let's just give the one that is known to work.
All right. So
you don't even have to reload.
Choose file. Cats are in there. And now it's working.
It's coming in quotes, right? Application JSON in quotes. So it's returning a string, not a number. That's funny.
Yeah. I think that's because I only returned the last part indexed to label. So it returns the label
okay.
here, which is a
with
which
the
is a
label, which is a
string.
string. So that's fine. So yeah, that's actually doing the right. Oh yeah, of course. Like it's returning like that's a dumb question. Like the model is returning some text, and the text just happened to contain the number 2. Yeah, nice. That makes sense.
All right. So now we have the code working. Now, would you put this into a dictionary, for example, or would you just keep it as a string?
Yeah, maybe it will make sense to put it in a dictionary in case later you want to add additional information. Yeah, so maybe it could be like returning like a dictionary saying like, yeah, I think like that works.
Yeah. Okay.
But like this is one of those things that depends a lot on the application and the conventions of the team, and like it's one of those things that is good not to be super strict about and to say like, oh, like the convention or like best practices are this or that. Is just like, yeah, well, what is practical, what actually works and solves the problem correctly. That's the main thing to do, I will think.
Yeah, good point. Okay, cool. So now we have a fast API that calls our model pipeline, a fast API app that calls our model pipeline. So now I think as a last step, we only have the Dockerizing part missing, right?
Nice. Yeah, I think so.
So let me stop the server with Control-C, and there is a kind of new Docker command that you can now use, which is Docker init. So with one of the latest versions, it should be available. So let me try to run Docker init, and what this will do, it will generate a Docker file for you, and also a Docker compose file and a Docker ignore file. So you have some best practices already in the beginning, and it makes it a lot easier to get started. So for example, here we can now select Python. Here it already suggests this is suitable for a Python server application, which is what we have. So let's select Python. And then you can, as a next step, select the Python version. So I just want to, let's keep the default 3.10 as Python version. Then the port, and then the command. So now this is something we have to write. So I think here we have to write the same command that we used before, if I'm not wrong. Unicorn main : app dash. Yeah, we could, while we develop this, we could do dash reload. And now we also have to. Yeah?
No, yeah, go ahead.
And now we also have to specify the port. I think dash port 8000. So the same that we use.
Yeah, and I think we also have to specify the host, because by default, Ubicorn will only listen on localhost, but localhost inside of a Docker container will mean that only whatever is inside the Docker container can talk to itself. And we need to be able to talk to the Docker container from outside the Docker container. So it has to be --host 0.0.0.0, which means like listen on all the IPs.
Very good point. All right. Okay, cool. And now let's hit enter again. And as you see, it now generated our Docker file, then a compose file where you can simply run Docker compose up later, and a Docker ignore file where, for example, it ignores a lot of folders already. So for example, here, let's also ignore the venv file without the venv directory without the dot. And now we need to do, in this case, we need to do a few adjustments. So first of all, but let's go over the Docker file very quickly. So here it suggests to select the Python 3.10 image, and then the slim version in this case. Do you have like any favorite images you usually use in the beginning?
I normally use the default Python version without slim, mainly because it simplifies like all the development and installing the dependencies and all the stuff. Later, at some point, whenever you have like the code running and like everything is working, and like you already have like the server working, and maybe you even have users already, maybe at that point it could make sense to try to optimize things. And then in that case, I will do like the install on a normal standard Docker image, and then probably copy the installed things inside of a Docker Slim image. But for installation, because sometimes it requires like things to build and compile stuff, it's just like, I think it's just like simpler and better just to have this like this. What I definitely don't recommend is using like Alpine or one of these alternative images, because they are super lean if you don't install anything on them. But if you need to install Python and all the packages and all the stuff, then they become like quite big, which is like equivalent to having like Python Slim or something like that. And in the Alpine images, you also have to install all the build tools, and then you have to compile custom for that image, which means that whatever was like the cost savings that you were making for using Alpine, then like you're spending that on like the computation of always installing and compiling everything from scratch. So whenever you need to optimize and squeeze things, then like Python Slim, if you don't have to squeeze things and like you need to build a product and like move fast, then probably just like not Slim at first, at least.
Okay, cool. Yeah, this is very helpful context. So yeah, like you said, let's use the normal Python image. And then, so here it sets up a working directory. Then in this case, it also selects creates it calls it non-privileged user. So this is kind of a best practice to have a new user that doesn't have all the permissions. And then here it says pip install requirements. So this is one thing we have to do inside Docker, of course. Then copy our code, and then in the end we expose the port, and then we run the command that we just typed in. So in this case, we need to save all the requirements in the requirements.txt file. So I already did this. So it's FastAPI, UVcorn, then Pillow and Torch and Transformers, and the Python multi-part is necessary for the file upload, I think.
Yes, that's correct.
All right, and now in this case, we also need to have the Rust compiler for the transformers. So I prepared the additional command that we have here. So let me copy and paste this in here. So we also need to get so this basically installs the Rust compiler and sets it as environment variable. And now to keep it simple, let's actually remove the additional user, because Hugging Face needs to download and save the model. And if we use this, then we don't have write permissions. So we could basically set specific permissions, but to keep it simple, let's simply remove this. And yeah, so this is now the whole Docker file. And now here it already suggests the command. So now we can type docker compose and then up and then -- build. So the first time it will then build the image. And this is because we also already have the Docker compose file generated for us. So this is a very simple file in the beginning. It doesn't have a lot of info in it. So it simply says that it starts in the Docker file must be in the current directory, and then it defines this port here. So let's run the Docker compose command and see if this already works. All right, so the Docker build process finished. And as you can see, we now again have our app running. So let's go again to our endpoint. And now we have the app that is running from inside the Docker container. So let's again test our endpoint, try it out, and let's select a different file. For example, let's select our tiger and then ask what is the tiger doing and execute. And again, we get our response. So now we have this as a dictionary with the answer sitting. So our tiger is sitting. So yeah, this worked. And now, again, so now we Dockerized our whole application simply with the Docker init command that makes it super simple. And in this case, we had to do a few slight modifications. And then we can run Docker compose up to have the container up and running. And yeah, so that's it.
Nice. That was much more straightforward than I thought we were gonna have like more issues and problems along the way, as always happens when like building something like. But yeah, that's awesome.
Yeah, that's true. But yeah, your help and your input was super helpful. You also gave a lot of cool tips along the way. So yeah, I really enjoyed the session. I hope you did too.
Yes, thank you very much for inviting me. Very fun.
Yeah, thank you.